Today we're going to be learning about box and whisker plots. So this is a continuation of 10.6. So what is a box and whisker plot? So a box and whisker plot is a graphic way to display the median, quartiles, and extremes of a data set. So this is the point in class where I would ask you, what we would know. What do you already know that we can apply to box and whisker plots? So I want you to just take a minute, pause the video, think about everything that you know that you've learned in the past about box and whisker plots. Hopefully you have a good list generated of what you already know. I know that you've done box and whisker plots in the past, but this is one area that I see seventh graders struggle with a lot. So I wanted to make sure that I did an entire lesson over it to help out those students that might not quite remember it. So for box and whisker plots, it's a lot of drawing. So what I'm going to do for this lesson is I'm going to show you some Khan Academy videos because he draws them a lot better than I could ever. So go ahead and watch this video.
An ecologist surveys the age of about 100 trees in a local forest. He uses a box and whisker plot to map his data shown below. What is the range of tree ages that he surveyed? What is the median age of a tree in the forest? So first of all, let's make sure we understand what this box and whiskers plot is even about. This is really a way of seeing the spread of all of the different data points, which are the age of the trees, and to also give other information like what is the median and where do most of the ages of the trees sit. So this whisker part, so you can see this black part is a whisker, this is the box, and then this is another whisker right over here. The whiskers tell us essentially the spread of all of the data. So it says the lowest data point in this sample is an 8-year-old tree. I'm assuming that this axis down here is in years. And it says that the oldest tree right over here is 50 years. So if we want the range, and when we think of range in a statistics point of view, we're thinking of the highest data point minus the lowest data point. So it's going to be 50 minus 8. So we have a range of 42. So that's what the whiskers tell us. It tells us that everything falls between 8 and 50 years, including 8 years and 50 years. Now what the box does, the box starts at, well, let me explain it to you this way. This line right over here, this is the median. This right over here is the median. And so half of the ages are going to be less than this median. We see right over here, the median is 21. So this box and whiskers plot tells us that half of the ages of the trees are less than 21 and half are older than 21. And then these endpoints right over here, these are the medians for each of those sections. So this is the median for all of the trees that are less than the real median or less than the main median. So this is the middle of all of the ages of trees that are less than 21. This is the middle age for all of the trees that are greater than 21 or older than 21. And so these essentially are we're actually splitting all of the data into 4 groups. This we would call the first quartile. So I'll call it Q1 for a first quartile. Maybe I'll do 1Q. This is the first quartile. Roughly a fourth of the trees, because the way you calculate it, sometimes a tree ends up at one point or another. About a fourth of the trees end up here. A fourth of the trees are between 14 and 21. A fourth are between 21 and it looks like 33. And then a fourth are in this quartile. So you call this the first quartile, the second quartile, the third quartile, and the fourth quartile. So to answer the question, we already did the range. There's a 42-year spread between the oldest and the youngest tree. And the median age of a tree in the forest is at 21. So even though you might have trees that are as old as 50, the median of the forest is actually closer to the lower end of our entire spectrum of all of the ages. So if you view median as your central tendency measurement, it's only at 21 years. You can even see it. It's closer to the left of the box and closer to the left, the end of the left whisker than the end of the right whisker. An ecologist surveys.
So now you know a little bit about box and whisker plots from his explanation. The important thing that I wanted to kind of build on, he was talking about each section representing a quarter of the entire thing. And so I know that's kind of hard to think about. So I like using percentages better than I like using fractions. So if you think about this whole entire box and whisker pot is 100% of our data. This is 100% of the data. We don't have any other numbers outside of here. This section represents 25%. This section represents 25%. So does this section, and so does this last section. And so each of these four sections is 25% of our entire data. What that tells us is they each have an equal number of numbers. So that means that if each section had 5 numbers, that's what it is. Each one of them has 5 numbers. It's just this section is a lot more spread out than that section is. So there might be a couple of them that have 10, whereas over here, there might be a little bit more spread out. And so that's a really important 7th grade concept, is understanding that the box and whisker plot spreads out the data and shows you each of the 25% increments. The reason that we have this big box here is because we really like looking at the middle 50%. And if we put these two sections together, it equals 50%. All right, so let's get into some questions. So the box and whisker plots below show the average amount of time a sample of 7th graders and 11th graders spend on homework each night. So this one represents the number or the amount of hours that 7th graders spend, and this one down here represents the number of hours that an 11th grader spends on homework. So let's go through these 3 questions. The first one says, is there a lot of overlap in the number of hours of 7th graders and 11th graders spend on homework each night? So let's go ahead and look at this. For this, we're probably going to want to think about the range of numbers. So the lowest amount of time is half an hour. So this is going to be our minimum. This is our minimum. Our maximum is going to be right here at 4.5. So that is our maximum. When we look at the 11th graders, our minimum is 1 and our maximum is 5. Do you see how I'm getting those numbers? I'm looking at the extremes and I'm just looking straight down to see what number that's at. If it's halfway between, because sometimes it will be, just kind of guesstimate. So as long as your answer is pretty close to what it should be, I'm not going to mark you wrong. So if we're looking for overlap in the number of hours we spend, this minimum is 1, this minimum is half. And so there's only 0.5 difference right there. If we look at our maximums, this maximum for the 7th graders is at 4.5, where the maximum for 11th graders is at 5. If we take the difference between those two, again, it's only 0.5. And so I would personally say that there's a lot of overlap because there is, let's see, 1, 2, 3.5 hours of overlap out of 4 hours total of your range. And so I would say, yes, there is a lot of overlap, and I would give that reason on why. I just cannot write it all on the screen, so make sure you're typing that full answer out. Yes, because if we subtract the 2 minimums and subtract the 2 maximums, there's only an hour's worth of difference. So if we add these two numbers together of 0.5 on both sides, it's only an hour difference, or half an hour on each side. Do any 7th graders, so let's move on to question B, sorry. Do any 7th graders in the sample spend more time on homework than than an 11th grader in the sample? So do any 7th graders in the sample spend more time? And so let's go ahead and clear that out. So we want to know if any 7th grader spends more time on homework. If we're looking at these two, we want to think about where our points are. So I know for a fact that this is one of my points. This is one of the points because it's the minimum. Same goes for this, except it's the maximum. And so I know at least one student in 7th grade is spending 4.5 hours on homework. And the same thing goes for 11th grade. I know at least one student in 11th grade is spending 1 hour on homework, and at least one student in 5th grade is spending at least, or 11th grade is spending at least 5 hours on homework. And so, since our question is asking, do any 7th graders in the sample spend more time on homework? We have to think about the individual points. Hopefully, you're thinking the answer should be yes, because if we think about this individual student that's spending 4.5 hours in 7th grade, they're spending a lot more time than this 11th grader that's only spending 1 hour on homework. And that holds true for the median right here of the students that are spending 1.5 hours on homework, because that's still more than the minimum of the 11th graders of spending 1. The only time that this question would be no is if there was absolutely no overlap between the two graphs. Let's go ahead and look at our last question here. Does it appear that most of the 11th graders spend more time on homework than 7th graders? Explain your reasoning. I want you to try this problem on your own. Keep in mind what I just said before, that each section represents 25%. So this is 25%, this is 25%, 25%, and 25%. So go ahead and try to answer this question. Pause the video. So hopefully you're thinking that this answer is also yes. So it appears that most 11th graders spend more time on homework than 7th graders, because this right here represents 75% of the students. So 75% of 11th graders spend more than 3 hours on homework, or 3 hours or more on homework. Whereas in 7th grade, 75% of 7th graders spend 2 hours or less on homework. And so this is the bulk of the data here. That's 75% of students. This is also 75% of students. And so it looks like the majority of 11th graders spend more time on homework than 7th graders. And that's the reason on why. Because if we look at each individual section and we group up 3 sections to make 75%, the 7th graders are spending 2 hours or less on homework, and 11th graders are spending 3 hours or more on homework. So I did a little bit of labeling in the last one. I want you to label the minimum, the maximum, the quartile 1, 2, and 3, and I want you to label the median. So go ahead and try it. Make sure that in the video he was saying that this whole thing represented the first quartile, which is true, but we're going to say that this is quartile 1 because that's where we're getting our data from. So when we look at our data, we're making this line by finding Q1. So I labeled 1 for you. This one should be labeled Q1. Go ahead and try to label the rest of this box and whisker plot. Pause the video. Hopefully your labeling looks somewhat similar to mine. So the minimum is down here, the maximum's way up there. Q1, 2, and 3 are going to fall right there. And remember that median and Q2 are the same thing, so they are synonyms. I have one more video over constructing a box and whisker plot for you to watch now.
The owner of a restaurant wants to find out more about where his patrons are coming from. One day he decided to gather data about the distance in miles that people commuted to get to his restaurant. People reported the following distances traveled. So here are all the distances traveled. He wants to create a graph that helps him understand the spread of distances. This is the key word, the spread of distances and the median distance that people traveled What kind of graph should he create? So the answer of what kind of graph he should create, that might be a little bit more straightforward than the actual creation of the graph, which we will also do. But he's trying to visualize the spread of information, and at the same time, he wants the median. So what graph captures both of that information? Well, a box and whisker plot. So let's actually try to draw a box and whisker plot. And to do that, we need to come up with the median, and we'll also see the median of the two halves of the data as well. And whenever we're trying to take the median of something, it's really helpful to order our data. So let's start off by attempting to order our data. So what is the smallest number here? Well, let's see. There's 1, 2, so let me mark it off. And then we have another 2, so we got all the 2's. Then we have this 3. Then we have this 3. I think we got all the 3's. Then we have that 4. Then we have this 4. Do we have any 5's? No. Do we have any 6's? Yep, we have that 6. And that looks like the only 6. Any 7's? Yep, we have this 7 right over here. And I just realized that I missed this 1, so let me put the 1 at the beginning of our set. So I got that 1 right over there. Actually, there's 2 1's. I missed both of them. So both of those 1's are right over there. So I have the 1's, 2's, 3, 4's, no 5's. This is 1 6. There was 1 7. There's 1 8 right over here. 1 8. And then let's see, any 9's? No 9's. Any 10's? Yep, there's a 10. Any 11's? We have an 11 right over there. Any 12's? Nope. 13, 14. Then we have a 15. Then we have a 20. And then a 22. So we've ordered all our data. Now it should be relatively straightforward to find the middle of our data, the median. So how many data points do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So the middle number is going to be a number that has 8 numbers larger than it and 8 numbers smaller than it. So let's think about it. 1, 2, 3, 4, 5, 6, 7, 8. So the number 6 here is larger than 8 of the values, and if I did the calculations right, it should be smaller than 8 of the values. 1, 2, 3, 4, 5, 6, 7, 8. So it is indeed the median. Now, when we take a box and whisker, when we're trying to construct a box and whisker plot, the convention is, okay, we have our median, and it's essentially dividing our data into 2 sets. Now let's take the median of each of those sets. And the convention is to take our median out and have the sets that are left over. Sometimes people leave it in, but the standard convention, take this median out and now look separately at this set and look separately at this set. So if we look at this first, the bottom half of our numbers essentially, what's the median of these numbers? Well, we have 1, 2, 3, 4, 5, 6, 7, 8 data points. So we're actually going to have 2 middle numbers. So the 2 middle numbers are this 2 and this 3. 3 numbers less than these 2, 3 numbers greater than it. And so when we're looking for a median and you have 2 middle numbers, we take the mean of these 2 numbers. So halfway in between 2 and 3 is 2.5. We can say 2 plus 3 is 5, divided by 2 is 2.5. So here we have a median of this bottom half of 2.5. And then the middle of the top half, once again, we have 8 data points. So our middle two numbers are going to be this 11 and this 14. And so if we want to take the mean of these 2 numbers, 11 plus 14 is 25. Halfway in between the two is 12.5. So 12.5 is exactly halfway between 11 and 14. And now we've figured out all of the information we need to actually plot or actually create or actually draw our box and whisker me draw a number line. Draw a number line. So my best attempt at a number line. So that's my number line. And let's say that this right over here is 0. I need to make sure I get all the way up to 22 or beyond 22. So let's say that's 0. Let's say this is 5. This is 10. That could be 15. That could be 20. This could be 25. We could keep going. 30, maybe 35. So the first thing we might want to think about, there's several ways to draw it. We want to think about the box part of the box and whisker essentially represents the middle half of our data. So it's essentially trying to represent this data right over here. So the data between between the medians of the two halves. So this is a part that we would attempt to represent with the box. So we would start right over here at this lower, this 2.5. This is essentially separating the first quartile from the second quartile, the first quarter of our numbers from the second quarter of our numbers. So let's put it right over here. So this is 2.5. 2.5 is halfway between 0 and 5, so that's 2.5. And then up here we have 12.5. 12.5 is right over, let's see, this is 10. 10, so this right over here would be this halfway between 10 and 15 is 12.5. So this is 12.5 right over here. 12.5. So that separates the third quartile from the fourth quartile. And then our box is everything in between. So this is literally the middle half of our numbers. The middle half of our numbers. And we'd want to show where the actual median is. So that was actually one of the things that we wanted to be able to think about in our original, when the owner of the restaurant wanted to think about how far people are traveling from. So the median is 6. So we can plot it right over here. So if this right over here this is about 6. So that is, and that's a pink color. So this right over here is 6. And then the whiskers of the box and whisker plot essentially show us the range of our data. And so let me do that. I can do this in a different color that I haven't used yet. I'll do this in orange. So essentially if we want to see, look, the numbers go all the way up to 22. So they go all the way up to, so let's say that this is 22 right over here. Our numbers go all the way up to 22. Our numbers go all the way up to 22. And they go as low as 1. So they go, 1 is right about here. They go as low, label that, so that's 1. And they go as low as 1. So there you have it. We have our box and whisker plot. And you can see if you have a plot like this, just visually, you can immediately see, okay, what is the median? It's the middle of the box, essentially. It shows you the middle half, so it shows you how far they're spread, or kind of where the meat of the spread is. And then it shows, well, beyond that, we have the range that goes well beyond that. It goes, or how far the total spread of our data is. So this gives a pretty good sense of both the median and the spread of our data. The owner of a restaurant.
So now that you've seen somebody create a box and whisker plot, I want you to try to create your own. So I organized your numbers from least to greatest already. You just have to create your spread. So go ahead and try this problem out. If you need to, go back and rewatch that video, and then check your answer with me when you are done. So pause the video now and try this problem out. Hopefully your box and whisker plot turned out a little bit like this. So our minimum is at 4.5 because it's the smallest number we have. Our maximum is at 12 because it's the biggest number we have. After that, I found the median, which is the middle, or Q2. It is an even number of numbers, and so we don't actually have a middle number. So I took the average of 6 and 7, so I added them together and divided by 2 to get 6.5, which is going to be this Q2 line right there. To find Q1 and Q3, I find the median of the left half. So there are 5 numbers in the left half. So 1, 2, 3, 1, 2, 3. Brings me to 5, which is where my Q1 is. Q3, same thing, 1, 2, 3, 1, 2, 3. Middle number is 9. So my graph is at 9, my Q3. And so this is what it should look like. You are more than welcome to shade this in. You don't really have to, though. I have three questions for you. So you're going to be looking at this graph up here. Notice that there's kind of two graphs put together. So we've got male students and we've got female students. And we're going to see how many hours of sleep they get. And so we're looking at what is the lower quartile of male students. So answer that question. Which has the largest range? And how much lower is the median of male compared to our female students? So go ahead and try to answer these three questions on your own right now. Pause the video. And here are your three answers. So the lower quartile of male students, we're looking right here, and that is 7. We're looking at which has the largest range. So we figured out the range of female students and the range of male students. The range of female is 5.5 compared to 4.5 for males. And so females have this one. And then how much lower is the median of male than female? So we're looking at our medians, which are these lines right here. And so for males, that is 8.5. For females, that is 9. Subtract them because we're trying to figure out the difference between the two. So our it's 5.5 hours less. This is going to be pretty similar to what your homework looks like. So we've got, again, two different graphs, and you are analyzing each of these graphs. In your homework, you've got a few comparison questions, just like how we did on this last one, just at the bottom of them. So I'm going to do team A, and I want you to do team B. So for team A, the highest number of goals, we're looking at the maximum. And so our maximum for team A is 6. Our lowest is that minimum point, which is going to be 0. Our lower quartile, or Q1, is going to be this point right here. So if we look down, that is at our number 2. Upper quartile, opposite side of the box, Q3 is right here. And so that's going to be at 4. Our median is the middle, and so that's going to be the middle dot right here, which lines up to our 3. The range is going to be the biggest number minus the smallest number. So in this case, it's going to be 6 minus 0, which is going to give us our answer of 6. Our interquartile range is when we're looking at Q3 and Q1 and we are subtracting those. And so that's our upper minus our lower quartile. So 4 minus 2 is going to give us our answer of 2. So I filled out this for team A. I want you to go ahead and fill it out for team B. Check your answer with me when you're done. Go ahead and pause the video. Go ahead and double check your answers with mine. If you need more time to check your answers, go ahead and pause the video again. All right, so let's move on. So in class, I'm going to be asking students to come up with 2 truths and 1 lie about this. So go ahead and do that. I know that you're not going to be able to check with anybody, and that's okay, but do come up with 2 truths and 1 lie about this data set. So for example, a truth that you could have is the minimum number of hours of sleep for male students is 6 hours, because that lines up with that right there. You can do things that compare the two. You can get as creative as you want. So come up with 2 truths and a lie that aren't something that I just said. And your homework or your practice is going to be BB16. So if you need a little bit of extra practice, go ahead and get that IXL done. For closure, our closing question is, how do you find the median using a set of data that has an even number of values? So I'll give you a minute to think about that. Go ahead and pause your video. So when I'm talking about an even number of values, hopefully you were able to think about this. So I'm just creating a random list that has an even number. So 8 is an even number. When I'm trying to find the the median of this set of data, let's make it bigger. I know for the median, I'm trying to find the middle. And so I'm going to count 1, lower, 2, lower, 3, lower, 4, lower, and it's going to be somewhere right there. So the question is, how do you find that median? So if you weren't able to find it, or you were confused on what I was saying, go ahead and pause and finish up your thought process. So when you're trying to find the median of a set of data that has an even number of values like this one example below, what you're going to be doing is finding the mean of the middle. And so the middle is going to be between 4 and 5. So we're going to add those together. Once we add those together, we are going to then divide by 2 because there are 2 numbers up there. So 4 plus 5 gives us 9. 9 divided by 2 is 4.5. And so that would be the median of this data set. And that's how you find it using even numbers, is that process right there. So if you have any questions about this, you can send me an email. You can also go ahead and get some practice in by doing BB16. So that's just practice if you need it. It's not going to be graded or anything, at least not yet. But I will be giving you some homework problems as well. So if you have any questions, send me an email.